Okay, so in this section, we're going to talk about 8.4, which involves right triangle trigonometry ratios, but we are going to be looking for missing angles. Okay, so it's going to be similar to what you did in 8.3, but there is a slight difference. So inverse trig ratios can be used when you want to find the angle of a right triangle, okay? And so the notation, there's two different ways. We're going to use one notation, which has a little -1 exponent. That means inverse sine, okay? This notation right there. It doesn't mean that it's an exponent. It's just a notation used to denote that it is an inverse. In other courses, you might learn that sine -1 can also be written as arc sine of x. Okay, so those do mean the same things, but they mean inverse sine. All right, so on a calculator, you'll notice you do have these buttons, but they're usually like the blue function buttons right above sine, cosine, and tangent. So they are on scientific calculators. Okay. If you want to type this in on the computer, you can use the words arc sine and it will recognize that as well. Okay, so there is inverse sine, inverse cosine, and inverse tangent. And so this is the way that we're going to solve to find the angle. So what you'll notice is for this notation, the ratio is actually inside the trig function. Okay, so you take the sine of an angle, but to find the angle, you do inverse sine of the side ratios, okay? So you're still going to identify which trig ratio you want to use, and it's just anytime you want to find the angle, remember to take the inverse, all right? So you're going to set up the trig ratio. You're going to use the inverse trig to find the angle, and we're still going to use our angle answers to 1 decimal place, all right? So attention. I know I keep saying this over and over and over again. It does get confusing to students because they think, oh, well, I don't know when I use the regular trig word and when do I use the inverse trig word. So it's very clear cut. Anytime you want to find an angle, you use the inverse trig. Okay? So you might not write it correctly on the paper, but it does matter what you're typing into a calculator. All right? So let's look at example number 1. So everything is going to be based on the angle that's labeled of whatever they want, once again. So across from the right angle, this is my hypotenuse. With respect to theta, which is angle A that's labeled, this side is going to be adjacent. So remember, it's SOHCAHTOA. We have to think which trig ratio did they want to use. So I'm going to show you how the connections are made. So I can think, oh, well, if I have adjacent and hypotenuse, that's cosine. So we're going to set that up as cosine of our angle is equal to A over H. So my adjacent is 12 and my hypotenuse is 13. Okay, and so this would be a correct trig ratio, a trig equation. It's not incorrectly written. Okay, but the idea for inverse really comes from, well, I can't divide by cosine, so how do we get theta alone? So that's where the notation comes in. So in order to get this theta outside of the trig function, we have to remember the notation. So I can take the inverse of cosine. So I get theta equals inverse cosine of this angle, trig ratio. So 12 over 13. Okay, and so that's kind of the connection. So it's cosine of the angle equals adjacent over hypotenuse, but if you want to get theta by itself, that's when you use that inverse trig notation. So we're going to type this into a calculator. If you're using a computer, you can type in arc cosine 12 divided by 13. Okay, this is for the computer. If you're using a scientific calculator, it's going to look like what I show you next. So we're going to do, I hit my second cosine. So you notice how notation comes up and it already puts my parenthesis in there. And we're going to do 12 divided by 13. Okay. So I got 22.6 degrees. We're going to go to 1 decimal place. So theta is equal to 22.6 degrees. And that's what we were looking for. All All right, let's look at example number 2. Here is my angle, which is angle B. I've got that's the side opposite, and this is the side adjacent. So we have to remember what uses opposite and adjacent. Well, that's tangent. So tangent of our angle is equal to opposite over adjacent. So opposite is 7.7 over adjacent. Now, typically you don't leave decimals in a fraction, but we're not done with the problem, so it really is okay. If we want to get theta alone, then that means theta equals the inverse tangent of 7.7 over 14. Once again, if you're using a computer, you're going to type in arc tan. You can just type those words out, and then 7.7 divided by 14. Okay? So 7.7, 14. So I'm going to do second tangent. Make sure you see that little exponent. No, it's the inverse. And then it was 7.7 divided by 14. I got 28.8 degrees, and that's the size of the angle. I just want to double check. 28.8. Let's look at example number 3. So example number 3, here's our angle at the bottom. And so this side is opposite, and this side is opposite the right angle, so that's hypotenuse. So which trig ratio uses opposite and hypotenuse? Well, that's so sine. So sine of our angle is opposite over hypotenuse, opposite over hypotenuse. Once again, to get this alone, we do inverse sine of 6 over 12. I know 6 over 12 reduces, but you don't even need to reduce these ratios, okay? If you're typing this into a calculator, you're going to type in arc and then sine 6 divided by 12. So second sine 6 divided by 12. If you show me what you're setting up, I can figure out if it's the numbers you typed in, the wrong trig ratio, the wrong order, things like that. So I got 30 degrees exactly. Okay? And so theta equals 30 degrees. I would not write 30.0 because it's actually exactly 30. That's the only time you don't need a decimal place. All right, example number 4. Once again, we're going to have some applications. I always draw a picture, so get out some scratch paper on your student practice. On your quiz, show me what you're drawing. But we've got a 14-foot ladder, and it's used to scale a 13-foot wall. So I'm going to think, oh, here's a wall, because that's what walls look like. At what angle of elevation, so remember elevation was looking up, must the ladder be situated to reach the top of the wall? So I'm going to draw my ladder. And my angle of elevation, remember elevation meant I was looking up, and depression meant we were looking down. So this is what I would draw, because you want to draw a right triangle and then label the sides so you know what trig ratio to use. So it says a 14-foot ladder. So that means that this side is 14 feet because that's my ladder that's leaning against. And it's used to scale a 13-foot wall. So that means this wall is 13 feet. What is the angle of elevation? So that would be at the bottom because I'm looking up in order to reach that top. So I look and I think if that's my angle, I know this is my right angle. So I've got hypotenuse, and this side is opposite. So opposite and hypotenuse, that's sine. So we get sine of our angle is equal to 13 over 14. So theta equals arc sine or inverse sine of 13 over 14. Once again, type in arc sine if that's what you're looking for on a computer. So second sine and 13 divided by 14. Okay, I got 68.2. So 68.2 degrees. All right. So go ahead and give those problems a try and let me know if you have any questions.